So why don't we kind of get started? I'm going to go into module group 1, and first thing I'm going to do is open up the PowerPoint for tonight in the study activities. And then the second thing I'm going to do is open up the assignment, okay? And so you get familiar with navigating Packet Tracer and using the program for your assignment. We're not going to do your assignment tonight, but we're going to just open up the file and kind of mess around in there. So let me go ahead and open this up here. Anybody have any questions from the first class at all? It was pretty straightforward, a little bit of terminology and some concepts, nothing strenuous there. It'll kind of start picking up pace. So, it seemed probably you may have, depending on your exposure to computers, you may have thought it was easy, but it'll pick up pace here as we go. So, all right. And let me go ahead and also then let me open up out of the module group 1, and you may want to do this as well. Out of the module group 1 assessments there, your second item down, well, the third item, I guess, if you count the objectives there, your assignment. And remember the PDF file, if you open that PDF, it's just an instruction sheet. You can print it off if you want. You can make notes in it. Yeah, somebody had asked a question, well, why is the device blank and the IP address is blank here? It's because when you download it off their website, you might get delivered, they have variables for names and IP addresses. So it's conceivable that you get a different topology than the next person. And so the instruction sheet just kind of leaves it open. Okay, and so that'd be something like you print it on paper, you could fill in when you get delivered your assignment, you could fill in your device name. Now, it's that Packet Tracer activity file, the one that ends with a file extension of PKA. That's one we're really interested in. So go ahead and download that one. I'm going to save it, to my downloads folder and open it up here. And depending on whatever browser you're using, you'll either see an arrow down here for Firefox or you'll see it down here in Chrome. But go ahead and open that file up, and I apologize that it makes you log into Cisco. Now, if you hadn't logged into Cisco and you forgot your credentials for the Academy, there is an opportunity to say guest login, and you can just log in without using your credentials. But if you do that at home, you only have a certain number of guest logins before it kind of locks the program. So, all right. So this is actually your first assignment, and we're going to open it up and use it a little bit as we go along tonight. So I'm going to kind of leave that here. And we're going to get into Module 2. So it's broken into topics, and here's a list of topics. And so we should be familiar with navigating through the Cisco iOS. They call that the Internetwork Operating System, iOS. Okay, and exactly what is an operating system? Most computers or devices, smart devices on networks that we're using, have an operating system. Sometimes people call them firmwares, depending on the type of device it may be. But generally, we've got the kernel of that software, the system. Sometimes you'll hear it called system software. And that's what manages or communicates between the hardware in the software. So on a computer, the operating system, we'd be talking about Windows, Mac OS, Linux. On a phone, you'd be thinking Android or what? Apple iOS. Okay, those are the popular operating systems. And that software is managing the interaction between the different hardware components on that device, that physical device. Also, it's managing your ability to load other programs, the applications that you may use as a user. It manages different services it may spin up and use. So the kernel is a core piece of that makes that hardware usable. And when, with a computer, you may attach other peripheral devices. That operating system's going to load the appropriate device drivers and make that hardware usable and for the programs to be able to interact with that hardware. The operating system also provides a shell, and that shell is a means of the user, allowing the user to interact with that system. And it can either be a command line interface or, as we see in today's operating systems, a graphical interface. All right. So, GUI, graphical user interface, we see that with Windows, Mac OS, even Linux, GNOME desktop environment, and your smartphones and things have a graphical where you can click icons, bring up menus, that sort of things. We're seeing a lot of operating systems kind of actually allow for installs that don't include a graphical interface. So Windows, does anybody know the version of Windows Server that you install that doesn't have a GUI? I can't either. It just kind of, I just lost it myself. It's, yeah, well, we could Google it. We could do a Windows, GUI-less Windows, or non-GUI Windows. Server core, yeah. Yeah, exactly. So it provides a command line. You can do everything through PowerShell, and the command line but no desktop, no menus, no icons, that sort of thing. Everything's so very much like a bare bones Linux operating system with no graphical interface. They do that to make it provide less of a surface for errors or malware, bugs. It's a lot leaner, it runs faster, uses less system resources. And here's an example of what computing was like 30 some years ago, 30, 40 years ago. We had our desktop and our command line and issued commands from there, ran programs, did all our work from the command line. We'll be using a command line for the most part in the Cisco coursework. Of course, they do have applications that allow you to provide a graphical web interface to the switches and routers to do some activity, but a lot of times you end up dropping to a command prompt to do some of your work. So we actually go through all the command line interface and how to navigate the iOS, and we'll start tonight by doing that. There's going to be three main ways to interface with the switches and routers and program them. The first method is a console cable, and it's a physical means of accessing the device. So let me go ahead and give you an example of that here. So what you see here in the picture is something that ships with, it's called a console cable, and it ships with your Cisco routers and switches, and it allows you to connect to a console port. You usually see them labeled in blue, light blue, and they match the cables. They usually ship in light blue color. And that's a physical port that you plug into and gain administrative access to that device. So even before it's programmed to work on the network or do anything, it's accessible through the console port. Okay? We call that out-of-band management. And the reason we call that out-of-band management is because it's a separate physical connection that we use to gain management access. It doesn't rely on the network, our Ethernet network. The same, the network we use to send email and web browse and so on. Okay, when we talk about in-band management, that means that the same cable that goes to our network interface card and we use to web browse and we use to send email and do all our activity on the network, if we want to use that interface to the network and connect to devices to manage them, we can, and we can use protocols like Telnet or Secure Shell to do that and connect to them. We call that inline or in-band management. And that means it just goes through the same data connection that we use for our normal computer activity. So because most computers don't have a 9-pin, so what that cable looks like on the front end, you can kind of see the weird end there. It's a 9-pin serial adapter. And so that's what it looks like, 9 pins there. And most computers now don't ship with a 9-pin serial interface on them, especially your laptops and things. So what we did here in the classroom is just take that and connect it to what our normal serial connections are through our universal serial bus or USB. All the devices got USB ports on them. So this is something you can pick up, on Amazon or wherever, and it's a USB to serial RS-232 serial converter. And so that's what we have plugged into our computers. And we got a line back into the closet that we'll use to administer our switches and routers that way. Okay. If we go with Secure Shell or Telnet access, we can remotely connect to things. So we can go through the network. It can either be on our network, it could be out on the internet somewhere, and we can hit them as long as they've been programmed with an address. And does anybody know what kind of addressing we reference things on our networks today with? Yeah, they're called Internet Protocol or IP addresses. Okay? And so here's an example on the screenshot. You see they're going to 10.83.129.180. That's an example of an IP version 4 address. And they're remotely accessing that device, in this case with the Secure Shell protocol. And the advantage of SSH over Telnet is that when you console in with Telnet, it's a clear text conversation. So if anyone were to be able to capture the packets, they'd see the entire conversation in clear text. Not a good idea. You'd like that conversation to be encrypted, and that's what Secure Shell will allow us. And we use a freeware program called PuTTY. It allows us to make Secure Shell, Telnet, or SSH connections. There are other ones, TerraTerm, Secure CRT, a variety of terminal. I call them terminal applications. So let's go ahead. I'm just going to take you in. We're going to make a connection to the switch in Packet Tracer. So if you opened up that assignment file, the first thing you need to do, or when you're doing this for real and going to turn it in, I'll take off points if you don't have your name in there. and your email. So make sure that you put in your name and email in the user profile. That's the first thing that pops up. Okay, and when you say okay, it's going to say, hey, this thing's going to reset if the user information's changed. Are you sure you want to reset the activity? We're going to say yeah, because we're just starting it. Now, if you do a bunch of work and later want to change the user profile, you're going to have to do all that work over again. If you reset the activity or you change the user ID in the profile, you'll have to redo all the work you've been doing. So when you open Packet Tracer, just kind of notice on your taskbar there's going to be, you open a Packet Tracer activity file, such as the one that's on our Module Group 1 assignment page. An activity has a topology, a set of network devices, or the ability to build a network, a virtual network. And then you'll have, the activities have an instruction sheet along with it and a grading macro. So it goes through and it'll parse the devices and check the configurations to see if you've done what's in the instructions. Now, there are other file types you can save these things as. PKTs, Packet Tracer Topologies. Those don't include an instruction sheet or the grading macro, okay? So they're usually not something you're doing with your assignments. PKZs, you can actually import images. You can put in actual bitmaps or JPEGs and build out physical networks and have maps with different cities, and you can drill into and build wiring closets in different buildings. It's pretty robust little program if you really get into it. The PKZ means it'll zip it up and take all those images you've imported and zip it as a zip file. So when you're doing your assignments, you're going to open a PKA, keep it a PKA, because that's what I need to be able to grade it. So don't change the file format on it. All right, and the assignments will have, a little table, generally, listing the devices that are in the network, any particular interfaces we may be using on those devices, their associated IP addresses and subnet masks, which we'll get into later as we move along, the importance of a subnet mask. And then it'll list the objectives, in English. Here's what we're trying to do: configure the host names, IP addresses, save the running configuration, connect a couple hosts, and test connectivity between them. Very simple. And then below are the requirements. And then this is where you're going to kind of walk through and accomplish each of these tasks. And they're the graded items typically. So, all right. So if we want to manage, say we're using this little network, we've got a couple of computers here, and they're attached to two switches, network switches. So think of that just like on the rack here. I've got a switch here. Now this switch up top, these are older ones, and they actually have a console port on the back end. Okay, the newer switches include a console port up on the front of them, but this one has it on the back side, so you don't see it. But we've got a computer attached in with a regular network cable, patch cable we call them, and then the two switches are connected together, and you see the cable type's different. If you go down on the bottom left, you'll see a device pane where you can select different kinds of devices: computers, routers, switches, access points, throw a cloud in there for WAN, and then you've got this little lightning strike. It looks like an orange-yellow lightning strike. That's your cabling that allows you to cable up things with different types of cables. And this black dotted line, if you open up the cabling item, maybe it might be locked actually, that it's open. Sometimes the activities will lock these, but as you walk your mouse over the different kinds of cabling down here, it's very hard to see. People don't oftentimes overlook it. As I'm moving my mouse over them, it tells me what kind of cable it is. Okay? We're going to get into the differences in the cables that are used, but just kind of suffice it to say that this black solid one's a copper straight through or patch cable, we call it. Sometimes we might use what's called a crossover cable to connect up like devices, like two switches together. We don't usually have to do that anymore in today's networks, but it can be done. All right, so this is just kind of getting the devices connected together in a network formed. But if we want to manage, look when you hold your mouse over the light blue cable, it says console. So go ahead and click on that console cable, and then go and click on your computer, say student 1, for example. Okay, you have an option, and you're going to want to connect it to the RS-232. That's the serial protocol that's in use for console cables. Unless you've got a USB to serial adapter, which we're using in our classroom. Okay, and when you want to connect it to the switch, to manage the switch, all the fast Ethernet and gigabit Ethernet, when you see Ethernet, that's your data connection. That's what you're going to be using to send data to, and your regular computer, you're going to be connecting computers and devices to. Your console port at the top is what you're going to want to connect that serial cable to. Okay, and once you've got that second connection, that's your out-of-band management connection. The other solid black lines, your in-band, regular network connection to your computer's network interface card. Go ahead and click on your computer, and you see the front end of the computer here with the physical view. Go to the desktop tab along the top there, and you have on your desktop, you should have a terminal application. You all see terminal on the top row. Okay, if you click on the terminal, you can set the terminal parameters, the configuration parameters for that serial connection. And it's 9,600 bits per second, 8 data bits, no parity, 1 stop bit, and no flow control. Those are the default settings for a Cisco console port. When you set up an application, a terminal application on your real computer to make a connection in, you got to make sure you have these parameters set on it, okay? We're doing it in the network simulator, okay? We're getting our computer connected up through the network simulator. I'm going to have you folks use the real computers and switches tonight, and that'll be in just a few minutes. Okay, and hit OK, and you should get, hit the enter key a few times, you should come up with what we call a command line interface. Now, I'm going to go to Options on the main menu, Options and Preferences, Option and Preferences. I'm going to slide over to the Font tab, the 4th tab over. And you see where it says, the second section says Dialogues, and it says Command Line Interface, CLI, Courier New 8-point. Change your CLI, make it a bigger font so it's readable. I'm going to go 18 points. That's really huge? That's pretty big, but that'll be good. It's readable, right? Okay. Anybody need a hand? Okay. Yeah, options. Let's see. Edit? Oh, you're in the Mac version, huh?
Yeah.
Let's see, where is it in the Mac version? Let's see. You're going to want to use the PC in class because I'm going to be having you physically connect up in the closet and things as well. hit it. I don't know where it is here. We'll have to kind of fart around and try to find it. You'll be okay tonight. You just use, whatever font it's got. But fire up your computer too, because I'm going to have you physically connect up and you don't have a serial adapter for that Mac. So fire up that PC as well. I don't mind if you use your own laptop and stuff, but as far as like doing the work, you'll need to use these machines. They're all hardwired up in the closet, so you're going to need make use of those. Okay. And this is what we call a CLI, or command line interface. And the first thing you're going to notice is the question mark. Go ahead and issue the question mark on your switch. That is the help utility. Okay? That allows you to get a list of possible commands that can be executed in that particular mode. So when you first come into the command line, you're going to see the name of the device, the host name, we'll call it the host name. And then the symbol to the right dictates what mode of operation you're in. So the first mode of operation is a limited user mode where you can do kind of test diagnostics. You can do some show commands and display different things about the device and how its operational status. You can test connectivity with ping and trace route and see if you're connected in the network. But you really can't do anything to change the operation of that device until you enter administrative mode. Okay? So it's kind of like a limited user mode. Okay? And the command to elevate access is called enable. Okay? So go ahead and type in enable, and that'll get you into what we call, so the first mode is called user exec mode, or user mode. The second mode is privileged exec mode, or privilege mode. And that's your administrative access. You're now an administrator on the device. Now, you can go into different configuration modes and start making changes to that device. Setting passwords, changing interface addresses, changing the name of the device, encrypting passwords, and doing other configurations. Okay, so let me pop back to the PowerPoints for a second. You'll notice when you type the keyword enable, it'll take you from user exec mode with the greater than sign. You type enable, you'll get into the pound sign unless someone's password protected the device. And the pound sign or hashtag shows you that you're in privilege exec mode. Okay, and let me just make this a little bigger. All right, and then from there, if well, typically, if we're going to make changes to the device, we'll go into what's called global configuration mode. So we'll issue a configure terminal to get our terminal into global configuration mode. And from there, we can go into a variety of what we call sub-modes. So all the different aspects of that device, like the different physical interfaces or virtual interfaces or different means of access, we call them lines. You can individually go into those different areas of the device or aspects of the device. In your curriculum, you've got a video that kind of shows you how to navigate the iOS and get started. Okay? And probably now wouldn't be a bad time to get you guys connected in the closet to the real switches, and you'll see how Packet Tracer, how similar it is to doing it in the real world. Okay, so I'm going to get you guys connected in the closet here. So you see in the packet tracer network simulator, you've got a computer with what we call a patch cable. That's your network connection. That connects you to the switch. That's for your regular traffic. Okay, we put a second line called a console cable that is connecting to the console port of that device to manage it. Okay, so you're going to do the same thing in the closet. You've got two cable runs. If you look to the row behind you, you'll see each computer's got two runs to it. And if you look at the back end of the computers there, in the row behind you, you see each PC's got a light blue cable running to it, and it should also have that dark blue USB to serial cable plugged into the USB port, the one I was showing you at the start of class. And going into that is a green cable, a green network cable, into that serial to USB adapter. So you got two runs to your computer. One's for your network access to your NIC, your Ethernet NIC, and the other one's for your management connection. Look at your computer. Your computer's going to say, in Will's case, it's B2, right? It says B2, and there's a little white label in the bottom left corner of your monitor. And Will's is B2, and Andrew, right? Andrew's B3, and Austin, you're B5, right? Okay, and as we move down to Stephen, you're 7. You guys are 8 through 16, and then the back row's 17, and so on. Know your computer number, okay? And then also, you'll look, and you'll see a second number. Don't worry about the B24 to 48 number. That's no big deal. But do kind of remember your pod number. It's going to say pod 1A or pod 1B or pod 2A or B or whatever. I have everything racked up in the closet, so to kind of keep everything organized, you're all going to hook up into different equipment, okay? All right, so why don't I take the front row in, get you connected up, and and if you guys want to take a little break, you can while they're getting connected up. And then in about 5 minutes or a couple minutes, you guys will come in and get you connected up. Oh, and you're going to lose internet access, okay? So you're going to lose internet access on your PCs. Okay, so all the computers have cable runs. They all come up through the backside, up through the floor. Some of it comes through the conduit, through the ceiling. That's most of the wall ports. And all this stuff comes back in, and it's all punched down into what we call patch panels. That's to organize all the cabling in the network. So in this classroom, the 24 computers all come back in. All the cabling is punched down into the back side of the patch panel B. That's why I labeled them all B, whatever number. And then we use little jumper cables to take them into our Ethernet switch. That's the first device we see in our cable network. So I'm just going to unplug you from the regular college network and the internet, okay? And you're going to be plugging yourselves onto your own switch, your own local area network. You'll be setting up your own switch and your own network. Okay, so let me unplug these. Then I'm going to get you all connected. Okay, you're going to have two cable types that you use, so we'll get Will connected first. What computer are you, Will? B2. Okay, so you're going to plug that into B2. Get these out of the way for everybody. Okay, and then that, you B2, your pod 1A. So you look, I have all the equipment racked up and labeled. Pod 1 switch A, you're going to plug into any of the switch ports. That gives you your computer's LAN access or your Ethernet data access. This red cable's your console cable, and it's going to go immediately below B2. That's the second number.
Is that actually attached to that?
Yep. That's the second cable run to your computer. And this is going to go into the console port of the device you're going to program. So it's going to be the switch in this case. Yep. That's it. That's your two connections tonight. Okay, and Andrew, whatever computer number you're at. Okay, 3, and you're pod 1B, so you're going to go into any of those Ethernet ports. That's your network connection. Okay, and the red cable goes into your console port for management. Yep. And this goes into the port immediately below your other one. Okay, excellent. Austin, what computer are you at? 5? Okay. And then your pod 2A. So here you are here, and it'll be that switch. Okay, and this goes right below 5. Goes into your management port of your switch. Right here? Yep, exactly. That's it. Okay, Stephen. And your B, pod 2B. Okay, so yep, right in there. This goes into your console port. That's it, yep. Excellent. That's it, yep, exactly. Excellent. They're all hooked up. The second row guys can come in. Remember your computer number. Now, because you two guys are sitting at the same table and would normally be connected, Dion? Yeah. Dion and Trevor, I'm going to put one of you on a separate set of equipment, so you got your own equipment tonight, okay? So come on in. What computer are you at, Dion? B9. 9, okay. So go ahead and plug this into B9 up there. You'll see that. So come on in the wiring closet all the way. So all the computers have 2 cables run to them out underneath the floor, and it comes up through the bottom of the floor in the back of the cable rack, trays here. And it's punched down in the back side of the patch panels. That's just for organization purposes. And then we got little jumper cables that take them into the LAN switches. That provides them their network connection, their LAN connection. We're unplugging them out of the switch, and you're going to plug into your own switches over here and program your own LAN switches. Okay? So that's why you're losing internet access, because you're putting yourself on your own little network here. And Dion, you are pod 3A. So over here, all the equipment's labeled here. You're 3A, so you're going to plug into this switch here, one of these ports, and you're going to program that same switch. You can plug into the console port there, the light blue cabled. And if you would, just pull on that and grab the other end. Stick that into the port immediately below B9. That's the second cable run to your computer. Okay, you're all set. All right, Trevor, you would technically be on the same pod with Dion, but I'm going to throw you down on pod 5, so you got your own equipment. So go ahead and plug in. You can stay in the computer you're sitting at. If it's B10, then I'm going to put you down here on pod 5 in A. So you're going to be pod 5A. So you can plug into any of those Ethernet ports on the switch. That's your data connection. It goes to the NIC on your computer. This console cable you're going to use to manage your switch, and that goes into the console port of your switch there. You may have to flip it upside down. Okay, and that'll go into the port immediately below B10 over there on the patch panel. That's your two connections. One for data, one for management.
I'm B12.
Oz?
Oz, yep.
Oz? Just Oz?
Yep.
Okay. Oz, you're B12?
Yeah.
Okay, so that'll go in B12, like the shot, vitamin, B12. Okay, and then the red one goes immediately below B12. Okay, and then Oz, you're sitting, do you remember what pod number?
I don't.
Oh, that's okay. 12. Probably be, which computer is it? It's this one right here? Yep. Okay. That'd be pod 3B. Yeah, pod 3B. Okay, so go ahead and take your other end here. Your blue cable will go into pod 3B. Any of the Ethernet ports are fine. They're all the same. That's your data connection, and then your management connection is the console cable.
All right.
That'll go right in there. Okay, Dane.
Dane, yep.
Okay. Dane, what computer are you at?
15.
15, all right. There's your data, there's your console, and you got to be pod 4B.
This one here.
Yep. Excellent. Okay, perfect. Okay, so if you remember, how did we make that connection in Packet Tracer? Well, I'll do it on the other student computer here. We grabbed a console cable and we plugged it into the serial port, the RS-232 port of our computer, and we plugged it into the console port of the switch. And on the simulated computer on its desktop, they've got a terminal application that we made sure to use the Cisco default parameters for a serial connection of 9600 bits per second, 8 data bits, no parity, 1 stop bit, no flow control. Hit OK, and that's how we brought up a command line in Packet Tracer. Okay, how are you going to do it in the real equipment in the closet? Well, are you all set okay? You're all good? Okay. So go ahead and hit the start button and type in. Remember in the slides, they had a screenshot of Putty, P-U-T-T-Y. It's a free application you can download. Go ahead and type in Putty. Hit the start button, type in Putty, and open up the Putty app. Okay, and the type of connection you're going to use out of the 5 listed, it's the rightmost connection type over here on the right. Use serial on the right-hand side, serial radio button. You'll notice that the speed changes to 9600, and it says COM1 is the serial line. Well, Windows can associate a different communication port to it, virtual port, and we need to identify what port Windows is assigned to that USB to serial adapter. Does anybody know how we're going to do that? Device Manager. Okay, so open up the Windows Device Manager. You can, hit the Windows Start key and type Device Manager, or you can just right-click on the little Start button. If you right-click on it, you get a shortcut menu, and about a quarter of the way from the top is your device manager. Okay, it shows you the device is connected in the device driver details and stuff. If you expand the ports item, and you should see a prolific USB to serial COM port. Okay, if you don't, that means that your cable got, your plug got jacked out of the computer. Okay, y'all got a, under ports, prolific USB to serial? Raise your hand when I ask questions, raise it if you don't see it. Okay, and look at the back end there, you should see the COM port number identified. So mine's COM4, yours might be 3 or 5 or 1 or something. Usually it's between 1 and 10. Okay, and so I'm 4, so I need to make sure that I change that COM port number to 4. Okay, now that's all I really need to do in PuTTY. However, if you look down below on the left-hand side in the control panel on the left, you'll see an option called Serial at the very bottom in PuTTY. Okay? And don't those settings look familiar to what you saw in Packet Tracer? The 9600 bits per second, the 8 data bits, the 1 stop bit, the no parity, and the flow control can be none or X on, X off, it doesn't matter on that one. But those are the default Cisco console settings for a console port. Now you can change those rates, but you have to do them on the device as well as within PuTTY. So, but those are the Cisco defaults. The other thing you might choose to do, and this is just for preference, you might change the system, use the system colors instead of the black background and the monochrome, like green lettering foreground color. If you go to colors under window, you can say use system colors. It'll be a white background with black text. It's a little easier to read. And the other thing you might want to do is under window, you can go to appearance. And if you don't like a small 10-point font there, hit the change button and make it, 16 or whatever you're comfortable with. Okay, and once you've done that, you can just hit open. You'll need to click on the window and hit the enter key a few times. All right, and you should get some text, readable text, okay? Shouldn't be gibberish. It shouldn't look like wingdings, or you ever see the wingdings font? Okay. It should be readable text, and it could be a variety of things. Now, if you notice my prompt, it says SW-A. That means that this switch was configured. Okay, somebody changed the name of it from switch to SW-A. So it means it's got a configuration on it, booted with one. I don't know what other things have been done to it, so I'm going to show you how to change the to reset this thing back to factory defaults. So like on your home broadband routers at home, you typically have a button. You can stick a pencil in or a paper clip in, a reset button that'll reset it to factory defaults. I'm going to show you the reset to factory default process. There is no button on the switch to do that. It's through software that we do it. Has everybody got a prompt? Yeah. You don't? Okay. Okay, did you hit enter a few times? Now you're still at COM1. Is that what your USB port said? It says COM4. Mm-hmm. You were looking at the one above it. Yeah, so change your PuTTY parameters. Go serial. Make that COM4. Okay, now hit open. Hit enter a couple times. Okay, there you go. Now, Dion's getting on his. It says, do you want to enter initial configuration dialog? Raise your hand if you saw that too. A few of you did. Okay. If you saw that, that means your switch has been reset to factory defaults, and you don't have to do what I'm going to do. Just hit no to say no to the initial configuration dialog. Okay, just say no to the initial configuration dialog. All right, and hit enter a few times. You should come up to where it says switch greater than. Okay, if your switch says switch greater than, you're in good shape. You don't have to do what I'm going to do. If your switch has a different name, says something other than switch, you're going to want to do the following. Type enable to elevate access to privilege mode. Going from user exec mode to privilege exec. Somebody password protected this thing. I hope I know the password. Okay? So in the classroom, always use one of two passwords, unless I tell you otherwise. I'll tell you what password to use, but always use the password I ask you to use. It's going to be Cisco, lowercase Cisco, or lowercase class. Okay? So if your switch was password protected, when I type, you won't see any text when I type. So I'm just typing Cisco, and I hit enter, and it took it. That's what the password was. Okay, I'm in privilege exec mode. Now I can do administrative stuff. And what I'm going to do is wipe out what's called the startup configuration file or the backup configuration file that's in permanent memory. It's called the startup configuration. So I say erase space startup-config. Now if you need to do that on your switch because it says something other than switch there, you do it as well.
Mine says enter interface name used to connect to the management.
Okay, so you got into the setup mode. Okay, you're in the initial setup dialog and it's asking you questions. What do you want to name it? What do you want to use for the management interface? So let's see what we can get out of that here. Okay, I just dumped out of the dialogue there. So you're good. You don't have to do... You're in the dialogue too. You got into the dialogue somehow. It says enter. Yeah, so up here, before that, you must have gotten into the dialogue somehow. But usually you can break out with a Control-C. Sometimes the Control-C doesn't work to break out. And then you just kind of have to answer some of the questions and go through. But you're good now, Andrew, too. Okay. So it looks like most of you don't have to do this, pretty much. Yes, you can. So that's what I did. Yeah, Will. So one of the shortcuts you'll find is as you start typing, if you hit enough keys that get you out to a unique command, you can use the tab key to auto-complete the command for you. All right, and anytime you see a confirmation or an answer in square brackets, like it says confirm in square brackets, hit the enter key to accept that. Okay, you're seeing it says erase of non-volatile RAM complete. This is what we call a startup or backup configuration file. The permanent configuration. Stores the name of the device, the passwords, the IP addresses, all that unique stuff. Okay, I just erased that, and now what I'm going to do is reload the device. That's basically a reboot, a warm boot. Now, it's saying, hey, the configuration's been modified. Do you wish to save? This would actually reinstate what I just tried to delete and bring it back. I'm going to say no, because I wanted to delete it and come back with a factory default. process. Now this is going to take a minute for my switch to reboot. So, so I could walk in there and unplug the cable, the power cable, and plug it back in again. This is a warm boot, so the power is, you know, technically it still has, it's always got power in the process. Be the same as a restart in Windows, right? Okay, and it'll take a minute. So I'm going to pop back to the slides here for a second. Okay, and so we'll talk about the different sub-configuration modes. There's a good little video in the curriculum on slide 2 something in topic 2 there that shows you, you know, how to get around, type enable, disable. Disable will take you from privilege exec, the #, back to user mode if you wanted to go to limited diagnostic mode. Configure terminal gets you into global configuration mode where you can then enter those sub-configuration modes. If you want to back out a mode, go from one mode deep, back one mode, like from global configuration to privileged exec mode, you can type the keyword exit. It'll take you back one mode. If you're really deep in the modes, in the sub-configuration modes, and you want to back all the way out to the #, you can type the keyword end or do a Control-Z on your keyboard. Okay? We're going to use these, you know, during the course of the night here. A command, you know, starts with the prompt, and that tells you the name of the device and the mode you're in. Then, following, you know, the prompt, you start issuing commands, and you have a keyword and a parameter, or you may have multiple keywords and multiple parameters, or arguments that you pass those keywords. When we do things in the text, and then when you take quizzes and stuff in the Cisco Academy, they typically will bold the keywords. Those are commands. And then things that you would pass as arguments will be either italicized, they won't be bold-faced, and typically you'll see them in italics. So you'll be able to identify when you're looking at things in the text. You know, anything in bold is typically what is a command that has to be typed as is, exactly as is. These commands can be abbreviated. So, like, I know ping, I can abbreviate ping as PIN. That's far enough out that it only goes to one command. Enable can be abbreviated ENA instead of typing out enable. So you can abbreviate things. The tests, when you take the exams, they'll ask you to type the entire keyword. Okay, you won't be able to abbreviate them. When you take the Cisco certification exam, if you choose to do that, you'll also be required to type the full commands. It won't accept abbreviations. Okay, and we saw the help feature is the question mark. Okay, so let me see if I'm back yet. My switch is still booting. So these switches and routers, they take a while to reboot, don't they? You can see just how long it's taken to reboot. And that's generally not an issue because we don't typically reboot these appliances very often. You put them in, connect everything up, and they stay running for days, weeks, months at a time without any disruption. Okay, and another thing that we'll notice, so I can issue keywords and a question mark, and I'll see, you know, what parameters or arguments I can pass to it. Another helpful thing is when you're typing out commands, if you do a syntax error and you type an invalid command, it's going to let you know. So it's got a syntax checker that will kind of identify where you went off and did something wrong. The caret will kind of show you where things went off, and it'll give you a little bit of an identifier as to what the problem is as you're typing things. Okay, and again, you can abbreviate stuff. Here's another use of the question mark. If you type in CON with a question mark with no space in front of the question mark, it'll give you all the keywords that start with CON. Okay? If you type in CONF for configure, put a space and then a question mark, a space before the question mark will say, okay, what possible arguments or other keywords can come after that keyword? Okay? Not what are all the strings of text that start with that set of string characters. Okay, so whether you put a space in front of the question mark or not will change how the question mark works. If there's no space in front of the question mark, it'll give you all the keywords that start with that set of characters. If there's a space in front of the question mark, it'll give you all the available commands or keywords or arguments that can come after that keyword or argument. The tab key auto-completes something you're typing for you, if it's possible. Otherwise, it won't, you may be typing something that leads to nothing, and it won't complete it, obviously. You can backspace over the left character. You can use the left arrow to kind of back yourself up in a line, or the right arrow to move forward. It keeps a list of commands that you've been issuing. It's called the command history buffer, and you can use the up and down arrows on your keyboard to cycle through that command history. Okay, so let's practice with a few of these things. My switch is rebooted here. I'm going to say no to the initial configuration dialog, and I should be at a place where you are. Okay, so if you were in Packet Tracer, hey, this is exactly where we were. We were sitting at the switch prompt, programming a switch. Well, look at that. It looks just like the real thing, right? Okay, so we're doing this on the real switch, but the commands will work identically in Packet Tracer. Okay, so how do we get to be an administrator? Right now we're in what mode? User exec mode, user mode. How do I elevate access? Type enable. Give me an enable. Or you can just simply type ENA. Okay. Didn't ask me for a password now. Remember it did before? Asked me for a password? Well, that's because I erased the configuration file, rebooted, and now it's got a default plain configuration. No passwords are set or nothing. Are you all at the pound sign? Switch pound sign? Raise your hand if you're not. You're all good. Okay, perfect. Give me a configure terminal, or CONFT. That's short for configure terminal. And notice how your prompt changes. Let's get your host name switch, followed by config that says you're in global configuration mode. I can change the system time. I can change the name of the switch. I can start setting passwords on here. These are things that affect the device as a whole. That's why they call it global configuration. I could start going into particular pieces of the switch, like specific interfaces or specific protocols, and they would be sub-modes, okay, which we'll do here in a little bit. So why don't we first off change the name of our switch. So let's go ahead and call this, we're going to say host name. That's the command to change the name of the device. Host name, and then I'm going to do a question mark. And you see here, it says word. That means you're going to type something in, a string of text, and it's going to be the system's network name. It's the name of the device. Okay, so let's call it, it's in the V120 closet. So why don't we call it V120 SW1. And you can all use the same name because you're all actually on different networks, okay? So none of you are connected together at this point.
Why are we using, is there a difference between using PuTTY and like a regular command prompt that's on the computer?
Yes. So Andrew asked, what's the difference? Why are we using PuTTY and not a command prompt from our computer? Well, if we're at a command prompt in Windows or on Linux or Mac OS, we're affecting the computer. Right now, we're using PuTTY in a serial connection, and we're changing the configuration of the switch, not the computer.
So you can't use the default Windows command prompt to affect the switch?
You can if you use it as a means of telnetting or SSHing to that device. Yes. Okay. So usually when you're naming devices, you give them some kind of meaningful name. And like a switch, you typically would say, well, where's its, meaningful name for a switch would be its location, where it's racked on the rack, or its purpose. Those would be common ways of naming a switch. So there we go. It's first switch in the rack in the 120 closet. When folks log in, you can display a message of the day. So that is banner, MOTD, and then some kind of delimiter character that starts the message that you want to display. So most times you'll see people use the pound sign as the start delimiter of your message. So this is a login banner. When somebody logs into the device, boots it up, and they try to get a console window or session going, they're going to see a message. Okay, and normally it'd be something like a only authorized access permitted, blah blah blah, kind of a an access control statement or a legal statement of this. So I'm just going to type unauthorized. You can type whatever, say, unauthorized access prohibited or only authorized access allowed, something to that. Okay, and when you end the message, you end it with the same delimiter character that you began the message with. Now, you can actually hit the enter key and you can put in a multi-line message, so it can be multiple lines of text. It just, once you start the message with whatever delimiter character you use, once you type in that same character, that will be the end delimiter, and that'll be the end of the message. Okay, remember how when I first got in my switch, I was asked for a password? That was called the enable secret password. It was when I typed enable to go from user mode to privilege mode, to go from a limited user to an administrator, I was asked for a password. That's the enable secret password. Sometimes in the instructions, they'll just call it the secret password. Okay? And it's what regulates access from user mode, the greater than sign, to the pound sign. What allows you to elevate access and start doing some work. So let's go ahead and set a new password. Enable secret Cisco. So C-I-S-C-O. If you didn't know how to spell Cisco, there is another company called Cisco, and it's S-Y-S-C-O. Cisco, the tech company, is C-I-S-C-O, lowercase, go lowercase and all that. Now, if you use some other password, the next person in my next class that comes in, they won't know it and they won't be able to access the device. Okay? So please do not use other passwords. All right? It's okay if you do that in Packet Tracer, but on the real equipment, I'm asking you not to do that. If you do that, that'll kind of jack my class up the next time for that person, and I have to break, they probably, I don't usually stop the class and do a 15-minute. It takes me about 15 minutes to hack the password, to do a password recovery. Okay, so it involves on a router, you have to turn off the router, you got to pull the flash card out, you got to reboot it, hit a break sequence, put the flashcard back. It's a whole little process you've got to do to do that. So they publish the process. Any device you want to hack, there's a PDF on Cisco's website that tells you how to do it. Okay, and the key here is administrators change, people forget things, so you got to be able to bypass those passwords. Why is it not a security concern? Well, whoever breaks the passwords using this process has to have physical access to the device. They've got to turn the device off. They've got to hit a button or they've got to pull a flash card. They've got to have physical access to the switch or router. Okay, they can't do it from remote. So if someone has physical access to your closet, all bets are off. There is no security at that point. If someone has physical access to the equipment, there are no means of securing that equipment. It can be destroyed or, people can do things. So, okay, so that's the command, enable secret Cisco. That sets your secret password or your enable secret password. Okay, y'all need a break? Just a 5-minute break? Couple minutes? No? Yeah? You good? Raise your hand if you want a break. Otherwise, I'll go right till 8, or, close to 8. Good for an hour? Okay. All right. Okay, there are some lab activities. Remember, when you're going through the curriculum and you're reading your chapters, watch the videos. They'll go through and walk through and show you how to do exactly what we're doing in class. When you hit things that are extra packet tracers, remember, those are optional because you're going to have a packet tracer in your assignment. And there's 31 packet tracers strewn throughout the 17 modules. You're not going to have time to do them all, but if you want, you do have extra time and you want extra practice, you can do them. The labs, don't bother, trying to do them. They're set up so that you would either have physical equipment like us, or you would, have to build that network in packet tracer. It's just a PDF lab of what typically you would do in our wiring closet. Everything we're doing in class, we're covering what's in the lab materials. Okay, and so I just showed you how to set a host name. How do we name devices? Well, there are some restrictions on the host name. You got to start with a letter, okay? And you cannot have any spaces in the name. It has to end with a letter or a digit. It can only contain letters, digits, and dashes. It can have hyphens or underscores. Those are allowed. And it has to be 64 characters or less than 64 characters. If you want to return it to its default name of switch or router, you can say no host name. So this is a good slide in that I kind of tell you how to take the name off. And this is the way we usually undo most things. Like if we want to remove an IP address or we want to remove a user account, you say no. Okay? No undoes stuff. All right? So remember the no keyword. We use it quite frequently, and that is to remove something or undo something. Now, in class, I'm going to ask you to use Cisco or class as the password, but obviously you wouldn't want to do that in a production network. Okay, those are easily guessed, or somebody can use a password dictionary attack and easily break those access to those devices. So use something of 8 or more characters in length, a combination of upper and lowercase numbers. This is the password, not the host name. So your password, you can use special characters, spaces, all sorts of stuff. You can go as many characters as you want. Don't use common words, that sort of thing. If you are, kind of string them together and use passphrases. Password complexity, The longer the password, the better. And sometimes you can generate a passphrase that's pretty easy to remember, and yet very hard to crack. So, all right, and device access. So let's look at how we secure access to the device. So these are critical devices in our network. If somebody can gain access to the switch, they can bring the network down. Okay? So you want to make sure that you configure the devices with passwords. Now we've configured a password that the secret password they'll have to provide that as they elevate access to be an administrator. But we can also password protect the different lines of access or means of access to the switch. So in the closet, what port did we plug into for management access? The console port. Okay, so when they say line console 0, they oftentimes start numbering ports with the number 0 instead of 1. Okay, and so there is only one console port on the device, and they number it 0. They set a password on it, and that can be different than the one we use for the secret password, obviously. And the keyword login means, okay, when somebody comes in through that physical console port, they're going to be asked for a password. Okay? And the other way of accessing, and this is our enable secret password that we had already done. So let's go ahead and set that up. And then I'll take you in and we'll set up we call that the console password, the line console. That's called out-of-band management. We're using that separate serial connection to manage the device. So if you would, on your switch, can you give me a line console 0 or line con 0? You can abbreviate console as con. Okay, then give me a password class and the keyword login on the next line. It has to be on the next line. Are you all able to read my text there? All right? Okay. Okay, now watch what happens if I type the keyword end. Okay? If I type exit, it'll take me out of line mode back to global configuration mode. If I typed exit again, it would take me out of global configuration mode and take me back to the pound sign. If I simply type end or Control Z on the keyboard, go ahead and do that. It takes you all the way back to privileged exec mode. Okay, if you type exit again, it's going to log your session off. So go ahead and do that. Type exit again. So you typed end, got you back to the pound sign. Exit stopped our session there. Okay, and it says, hey, hit return or enter to get started again. Okay, if you hit enter to log, to start another terminal session, you're asked, first thing, see the banner message comes up? Hey, here's our banner. User access verification. This is asking you for a password. Now, we've used 2 passwords in class. We used Cisco for one password, and we used class. Which one works? Class. Class, that last password, is password protecting the console line. We're not even at a prompt yet. We don't have a prompt yet, and we're now being asked for that password. It should be CLASS. Now remember, whenever you're typing passwords, it doesn't show anything. Dots, nothing. When somebody's looking over your shoulder, unless they're looking at the keyboard or they got their phone out, always be wary of people with their phones out. Okay? Because you never know if you're, at your ATM or whatever you're doing, if they got their phone, they can be taking video, right? They may be thinking, acting like they're on a call or texting or something, but they can be taking video. So if someone's looking over your shoulder, they call that shoulder surfing. And that's a social attack, social engineering attack. So we use the console password that we had configured. We're now at user mode. How do we elevate access? Enable. And now I'm being asked for my enable secret password, the secret password, which we set as Cisco. You know, why do we have these different passwords? Well, we might want to give a junior administrator the ability to get in a switch and see if the interfaces are up and it's connected to the network and it's working, but maybe we don't want to give them access to be able to change the configuration. Well, we could give them the console access password, but not give them the secret password. And they'd be able to get in and issue some show commands and diagnose issues, but wouldn't be able to change the configuration. All right. Y'all okay with the difference between the two passwords? Okay, now remember, this is what we called out-of-band management, meaning we have to use a separate cable and plug into that console port. What if the switch is in the rack on the second floor and I want to manage it? I'm not going to run a cable upstairs from here, you know, and plug into its console port. I could use Telnet or SSH to use the regular data network to access that device. And we call that not out-of-band, but in-band management. Okay? As long as that device has an address associated to it that I can get to. Okay? And that the device has been configured to allow remote access. Okay, so let's go ahead and configure a Telnet terminal connection through the Telnet protocol or SSH. We're just going to configure Telnet for now. There is more stuff that we would have to do if we want to have secured, encrypted conversations. There's a little more setup to it. Not much, just a few more additional commands. But we cover that later in the class. So, whoops. Well, the way to get to it is line VTY 04 or however many concurrent sessions you want to allow. Now, you see here in the curriculum, they say line VTY 015. It allows for up to 16 management connections through the network at once. Now, don't do this right now. See, you're going to want to type configure terminal, and you can do that. If I issue line VTY 015, this is a valid command. It's on your PowerPoint slide. If I issue that, I actually get an error message. And the reason I get an error message, even though this is a valid command, is because I'm issuing it in the wrong mode. Okay? So these commands are what we call context sensitive. Only certain commands work in certain modes. Okay, so before I can make any changes to the device, I'm in administrative mode, but I need to get into what's called global configuration mode. So before that command will work, I've got to issue a configure terminal, or conft. Now I can issue the line VTY 015. Okay, and you know, while that syntax checker is somewhat helpful, it's not overly helpful because it wasn't an invalid input. I mean, in the sense that it's a legitimate command. It was just issued out of context. Okay. All right, and so let's password protect that means of access. So let's go ahead and use the same password we did for the console, which was class. So say password space class. And be careful, if you hit a space bar after class, then the password would be class space bar, you know. So, you know, when people type a word or a name, the natural thing is to hit the space bar, and that's a very common thing. So a lot of times I'll get someone who will call me, you know, former student or something, or is in class here, They'll say, hey, I wrote the password down. I know the password when I set it up. I wrote it down in my notebook, but I can't get in. And I'll usually tell them, first thing I say is, well, check is your caps lock key on. That's a common one because the passwords are case sensitive. The other one is put a space after it, okay, and see if that works. And usually one of those two things work. Okay, and then to institute the password, you do have to use the keyword login. That means when somebody tries to log in there, they're going to be prompted for that password. The other thing that they don't show you in this chapter that you might have to do on a device to get it to work, Telnet to work, is you may have to say transport. Go ahead and say this. Transport input. And I'm going to do a question mark for you. Say transport input question mark. Okay, this tells you, you let it know what protocols you want to allow in-band management with. Now, which ones secure? SSH, okay? That takes a little more configuration. We'll do it later in the thing. So if I only wanted to allow SSH and not allow the insecure Telnet connections, I would say transport input SSH. Telnet connections would not be allowed, okay? Now, if I want to allow Telnet, I can say transport input Telnet. I can say transport input Telnet SSH, or I can say transport input all. Let's go ahead and say transport input all. That's the default setting usually, but sometimes somebody may in the past have said transport input SSH, and you try to Telnet and it doesn't work. Well, this will fix that. Okay. So what I'd like you to do is to go ahead and at this point we've done several configurations. Where are these configurations being stored? Well, RAM, random access memory, in just we call that volatile memory because why? You lose power or you restart it, that information disappears. Okay, so that configuration stuff that's stored in RAM, we call it the active configuration or the running configuration. When we want to save that information to a non-volatile source, storage, we'll say to non-volatile RAM, we will say copy running config, startup config. Copy run start for short. So if you would, give me a, let's see, what are some of the other things we want to do here, just basic stuff. Go ahead and type end, if you would, and give me a show run. I'm just hit the tab key so you can see the full command. Show running dash config. Okay? That will show you all the commands we used to set up this switch so far. And some of these are, defaulted commands or settings in there already. So as you start at the top, here's your host name, here's the secret password, and this is the number shows you the type of encryption or hashing algorithm that's used. And then this is the hashed password. This is the MD5 hashed password. So what was it? It was Cisco. Okay, but it's stored as a hashed string. So if you look down, hit the space bar several times and get to the bottom. This isn't so nice. Look at my console password and my Telnet password stored in clear text. So if somebody's looking over your shoulder, they now identified the password to access the device. Not so cool, right? So you can, I'm going to do a Control-C to get back to the prompt. You can encrypt those passwords. Okay, so if you would, go ahead and do a configure terminal to get to global configuration mode and type in service password dash encryption. And I'm using the old tab key to autocomplete stuff. But the full command would be service space password dash encryption. Yeah, I kind of abbreviated there. Now, if you do a do show run and get down to the bottom, you'll notice here actually you can do this if you want. You can space bar all the way to the bottom, or you can say, here's another shortcut for you. The show commands display information, but they're only available in user mode and privilege mode. If you wanted to use a show command, typically you'll see the curriculum say exit or end, get you back to the pound sign, and then issue the show command. But then you might want to go back and reconfigure something, so then you have to hit configure terminal and so on. If you want to issue a command out of context, meaning where it's normally not available, the do command typically lets you do that. So if you say do show run, oh, and I'm sorry, I'm going to do a control C. I'm going to say do show run. The pipe sign lets you do different filtering of the output. So I'm going to say do show run. Pipe sign is the shift in the key right above your enter key. So it's a shift backslash. I'm going to say begin line console. I'm going to say do show run begin. I just did the up arrow. Line con. Sorry. So here's what I typed. What that did is jump right down. It said begin your running configurations. Don't skip over all that stuff we're not concerned with, and just start the output where it says line con. Okay? And you see here, now look, here's my password class. It's been encrypted. So somebody looking over your shoulder, they won't identify the password. Okay? So I will warn you, and I'll show you next time when I have internet access, but you can just Google type 7 reverser, and there are places that have online tools that can decrypt that in a fraction of a second. Okay, so it's only really good for shoulder surfing. If somebody is able to get that text file, they can reverse the passwords pretty quickly. Okay, so like I have students that will come back to me years later and say, hey, I'm configuring this firewall. Can you help me with the access list or something like that? And they'll send me a text file, a configuration file, and they'll think because it's encrypted in the text file, it's okay to send, that they're not giving me the key to their network. They're just asking me for help on something. But they're really giving me the password in, okay, too. So not that I would exploit that. I'm a nice guy, but you just want to be careful of that. Okay. Where are we at? We're really close to gaining remote access to this device. Remember I said what's required of a device to be able to access it remotely? That device has got to be assigned an IP address, okay? So on a switch, these are called, we're going to talk about layers of communication, like the OSI model and the TCP/IP stack. This is what we would call, in the next chapter, a layer 2 switch, okay? And a layer 2 switch does not operate or switch data based on IP addresses. It uses a different kind of addressing. Does anybody know the name of the kind of addressing that is used in Ethernet networks? MAC addresses. media access control addresses. So it's okay if you don't know that. We'll be talking about it later. But these ports, none of these ports get assigned IP addresses. None of the physical ports on a layer 2 switch will be assigned an IP address. So in order to remotely access this switch on the network, we've got to create a virtual interface. And that's called a switched virtual interface. For now, we're going to use interface VLAN 1, virtual LAN 1. So if you would, at the global configuration prompt, type interface, or INT for short, virtual LAN, VLAN 1. That's the number 1, not an L. You're going to set the IP address. So you're going to say IP address, the IP address you want to use. So let's go ahead and use a 192.168. Oops. Actually, let's back up here. Go ahead and use a 10.0.10.10. 10.0.10.10. Okay? And whenever we're setting an IP address, we have to also provide what's called the subnet mask. And so I'm just making these up, okay? And we'll talk about them later. In this case, this particular switch, you have to, if you do the question mark, it'll tell you how it wants the next parameter. You cannot use the bit count format of the subnet mask. It's got to come in the dotted decimal format. Okay? So if you would, give me an IP address 10.0.10.10 with a space and a subnet mask of 255.255.0.0. That's the full command in its entirety. Okay, the next thing is that would allow the switch to be accessible on the LAN. If you want to be able to access it from a different LAN or from the WAN, potentially, that switch is going to have to know the address of the router so that it can be gotten to and can talk back to a device that's not on its network. It has to pass it to the router. The router is commonly referred to as the default gateway. Have you ever heard that term, default gateway? Okay, so let's go ahead and program in the default gateway for this switch. This is all fictitious at this point. We're not setting up a router tonight. But it is the, you want to back up, say exit. Notice how exit just takes you one level back. Give me a IP default dash gateway. I'm not a fast typer. I use the tab key there. IP default dash gateway, and this would be the IP address of your router. Okay, so like in a real network, these switches connect to other switches, and at some point they're probably going to be connected to a router. And so this one has an Ethernet port on it. This is a router right underneath this switch. Okay, the job of switches are to connect up a bunch of devices in the LAN. They got a lot of ports. We say they have a high port density, a lot of ports. Okay, routers have a low port density because their job is not to connect up a bunch of devices, directly. Their job is to connect switches to other switches. Their job is to connect networks up or subnetworks up, or your LAN to the WAN, your service provider. So they have a different role in the network. So here's we're going to make a fictitious gateway up. 10.0.10.11. 10.0.10.11. There are some significance to what I'm just making things up, but I'm I'm careful not to duplicate the same address. So no two devices on your network should share the exact same 32 bits, the same numbers in their entirety. But they should share a portion of their network, a portion of their IP address should be the same. It's like everybody with a telephone in the same area code has to have the same area code prefix, 772 in our case. But then everybody needs a local dial number that's different from every other phone in that area code, so they got a unique phone number. Call gets routed to them only. Same with computers. So part of the address, in this case the first two numbers, reference the network number or subnet, and the last two identify who you are on that network in this case. Don't worry about that right now. We get into that in much more depth later. So just remember, this is what we call a switched virtual interface. We're assigning an IP address so we can connect to it through the network. This is the actual command that does that. And we're telling the device who their router is, how they leave their network and go to other networks. Okay, now if I want to connect to it from my computer, through my data line, not through the console connection, but through my regular network card, meaning I could maybe be connecting to a switch on the 3rd floor to program it, okay, instead of having to run a physical console cable up there, which isn't feasible. Our computer's got to be assigned an address that works. Okay, so let's go ahead and get on our computer. And you should see down on the taskbar something that looks like I guess it's changing in Windows all the time. So usually it looks like a computer monitor with a plug on it, but now it looks like a globe because I don't have internet access. But do you see where you click on it and it says network and internet settings or something to that effect? Okay, if you go to your network and internet settings and click on do y'all see Ethernet on there? Okay, and there's all sorts of ways to get there, and none of them seem to be fun. If you go under related settings, I'm just going to take the change adapter options. Change adapter options. And you see these adapters. Some of them are software, virtual. Some of them are real. And the one that says Ethernet, and it says Realtek PCI Express Gigabit Ethernet family controller, that's your physical NIC. Okay, go ahead and right-click on it and say Properties. Right-click on it, say Properties. And here's your services and protocols that have been installed for that adapter. And you should see the Internet Protocol version 4 amongst the list there. Go ahead and double-click on it, and let's change the address. Does yours say obtain the IP address automatically? Okay, that's normally how it is. For most workstations and things like smartphones and stuff. You bring your smartphone in, it connects to the wireless network, and then gains an IP address automatically. And computers can do that on the wired network as well. What service has to be on the network in order for you to get that IP configuration? DHCP, Stephen says. That is the Dynamic Host Configuration Protocol. There's got to be a switch, a router, a firewall, an access point, a computer that's serving up IP addresses on the network. Okay, some device that's going to, usually it's at home, it'd be your broadband router, right? Okay, so go ahead and say use the following IP address. We don't have a DHCP server on our little networks in the closet. So we're going to manually or statically assign the IP address, the subnet mask, and the gateway address. Okay? So go ahead and say, use the following IP address, 10.0. Make that a 10 sorry, 10, 10, 0, 10.20. You can have a subnet mask of 255.255.0.0. And do you remember what we set our gateway up as? Yep. Okay, so on our little network, go ahead and set your computer up as 10.0.10.20. That's an unused number there. 255.255.0.0, and the gateway we set up as 10.0.10.11. Now, we're not setting up a router tonight. We'll be doing that other nights. The DNS settings, why would we need a DNS server configured down here? What does DNS do for us? Does anybody know? Domain name service or domain name system. It's what resolves names to IP addresses. So without it, you would have to know the IP address of Kmart.com, its website. Okay? You wouldn't be able to say www.kmart.com without having a DNS service available. Okay? It's what automatically resolves. They're the devices that will resolve those names to IP addresses on your local network or out on the internet. Okay, so you don't have to fill in these settings down below here. Mine are just from my setup there. I'm going to say OK. Whoops. Got a little crazy there. Say OK twice. Okay, for it to institute the change. You have to say OK twice. Otherwise, Windows won't institute that change. Okay. You can leave it here, or if you close that, it's no big deal. I'm just going to leave these windows in the background. We'll come back to it later. If you would, let's bring up a command prompt and test connectivity to our switch. See if it's accessible. So I hit the Windows button and I'm typing command or CMD for a command prompt. And this is what Andrew was getting at earlier. Hey, well, our computer's got command lines. Here it is, right? And we can test connectivity by using the Packet Internet Groper. If you ever wondered what ping stands for. Okay. And we're going to ping the switch at 10.0.10.10, right? Wasn't that the IP address that we set on our switch? Okay, and did you get at least one reply back from that address? No? Okay, that means a physical or a software issue. I'll come around and take a look at it here. You should get a reply, and not only get a reply, but make sure you get a reply from the address you pinged, okay? Because you can have an error condition, you can get a response, but it may not be from the device you're trying to get to. And then it'll let you know your round trip time in milliseconds. So we got a solid connection there to our switch. Steven's got an issue. Anybody else? You're all good? Okay.
Did I miss the command or just enable that?
It all looks good. Here, maybe try this. Go back to your setup on your PuTTY and type go interface VLAN 1. Okay, enter, and then say no shut, S-H-U-T. Okay, enter. Let's just see if it was down for some reason. Did it change state? Let's see. Line protocol, change to state up. Okay, that's what it was. So occasionally, it's not usually the fact. Usually those virtual interfaces will come right up, but occasionally they'll be down. And The command to turn an interface down is the shutdown command. The command to bring an interface up is the no shutdown. So why didn't they just say on and off? I don't know. Shutdown means turn it down. No shutdown means do the opposite. Okay. Now, what that means now is I've got a connection between me and the switch. Not through the console serial line, through the management connection, but through my regular data connection that I'd be sending email and web browsing and doing that stuff through. So, theoretically, this switch could be out somewhere on the internet or on another place on campus, and I'm getting to it. So let's go ahead and PuTTY to it. Let's use PuTTY, the application PuTTY, and the protocol Telnet to actually make a Telnet connection in band through the network to our switch. So go ahead and bring up another PuTTY application window. And instead of using the default SSH, which is secure and the more appropriate means of managing devices, we're going to use the insecure clear text Telnet application for now. And Telnet to the IP address of 10.0.10.10. That was the same address we just pinged. That's the address of your switch. Okay, hit enter, and you should see the banner, unauthorized access prohibited or whatever you said. The password is your Telnet password, your line VTY, your virtual teletype password, which we configured as class, C-L-A-S-S. When you type in class and hit enter, you should get a prompt. If you want to elevate access, you would type what? Enable. You'd be prompted for the password, which is the secret password of Cisco, and you'd be programming that switch. This switch could be on the 3rd floor, could be on another building on campus, could be somewhere out on the internet even, potentially. Okay? All right. Excellent. 7:30. We're making, now I'm going to kind of slide through some of these PowerPoints pretty quickly. We've done a lot of them, talked about them already. So remember the old message of the day? We did that. So, hey, we've done a lot of stuff that we want to keep. How would we do that? Okay, we'll bring up your switch prompt. I'm going to the one PuTTY session that has my IP address in it. I'm going to just close that one out, okay, so I don't get confused. I'm going to exit. Okay, it closes that in-band management connection. And I'm going to open up PuTTY, my one that I had through the serial line, through the COM port, my console session. And the password was class to log in. And I'm going to do an enable and a password of Cisco. That was my secret password, or my enable secret password. What I'd like you to do is type in show start or show startup-config. If you had booted your switch and it said, do you want to get into initial configuration dialog? That's a sign that your switch had no configuration to begin with. No configuration in non-volatile memory. Everything we've done tonight is just been stored where? RAM, in volatile memory called RAM, and it's called the running configuration. So if somebody was to run in and unplug the power, or this thing power cycles for whatever reason, we lose everything we did tonight, right? We would want to make sure that we do a copy running-config, startup-config. Okay, so only do this if you have used the passwords I've asked you to use. Okay? Do not do this if you've used some other kind of password. Okay? Because that'll make me have to do a password recovery. So go ahead. If you use the passwords I asked you to use, give me a copy, run, start. That is short, abbreviated, for copy running-config, startup-config. And you see it says startup-config in square brackets. We'll hit the enter key to accept that. And now, if you say show start, you see the same set of information that we did when we did a show run. If you want to page through a page at a time, you hit the space bar. I should have mentioned this before. If you want to go one line at a time, you just hit the enter key to go one line at a time. If you want to display a page at a time, you hit the space bar. Okay, and you see all the configuration that we've done tonight. Yep.
Now, does it save anything or archive anything in a text file somewhere? Or?
Okay, so very good. If you want a running log, you want to keep track of the commands you've been issuing and the output and everything, you can configure PuTTY to do so. So if you go up to the PuTTY icon in the upper left, you can go to change settings and go to logging, and you can say all session output and push it to a file called, whatever you want to call it, putty.log. You can put it to whatever, it's in the program files PuTTY folder, but you could throw it on the desktop. And so everything, I'm going to leave it putty.log and throw it on the desktop, but all that stuff will be pushed into that text file. Only good for from now on, right? So all the stuff we've done before, I didn't keep track of it. The only method I have of looking back a little bit is the show history command. Show history. I'll see the commands I've issued in a particular mode. If I do a config T and do a show history, you'll see a richer set of things. We've been doing more, do show history. No, I guess not. Because we had exited, I got booted out, I got timed out. And so it's only good for as long as the session is. But you should see a text file on, and if you wanted to capture your configuration, you just say do show run or do show start, and that output that comes out. Just space through the whole thing. These are all the commands you'd use to reconfigure that switch. They're getting saved to that text file. Yeah, thank you. Get me back to the desktop. There's my PuTTY log file. And you can start seeing all that being captured. And you can clean that text file up, clean it up a little bit, and you can use it as a template and whoop, reconfigure a device. Just go into global config mode and paste it right back in. You can get a switch configured in just a few seconds. Yeah. Just have to make sure you clean up your passwords because they'll be in an encrypted format. You got to make sure you clean that up, and there are a few other things I'll show you during the course of the semester that you'd need to. You can do things in Packet Tracer, set up networks and routers and switches, and you can configure them. You can dump that out to a text file and throw it on a real switch or router, and it'll work. Yeah, exactly. It's kind of cool. Exactly. Yep. Okay. We're doing pretty good, everybody. If you just hang in there, we're getting there. 60 slides, we're on 38. We're going to make it fairly quick. There's not a whole lot left. We did that copy, run, start. If you ever wanted to go back and wipe out your configuration, start from scratch again, remember the erase startup config and reload command will reset that device. Now there is another thing you would need to do on one of these switches, and that would be if you wanted to delete the virtual LAN configuration, you would need to say delete vlan.dat, erase startup-config, and then reload. That's something we talk about in the next class, semester. Oh, there's the logging to a text file. Ports and addresses. Here's how you set an IP address on a Windows computer. On a Linux OS, you can do it through their GUI, or you can do it at the command line with an ifconfig. In the Cisco iOS, remember it's the IP address command, specifying the address and the mask. And the gateway setting is a separate command that you would issue, the IP default-gateway command. This is structure of an IP version 4 address. We're moving to IPv6. Things are already, many networks are already dual stack, meaning they're running more than one protocol. Windows has been dual stack for a long time. If you go back to your network settings and right-click on your Ethernet adapter and go to Properties, scroll down, and below IP version 4, you'll see IP version 6. And if you double-click that, you can set an IPv6 address. And they're not as fun to work with unless you really have an abbreviated format you can go with. Remember how you can see, anybody issue the command in Windows at your command line in Windows to see your current IP configuration? Have you ever done that? Yeah, IP config, and usually tag it. Yeah, a /all. Give yourself this is your Windows command line. Give yourself an IP config, all one word, IP config /all. ALL. And you can use a space or you don't need a space, it doesn't matter. I got a lot of output, and some of that's virtual adapters. But if you scroll up, remember the physical adapter is the Realtek PCI Express Gigabit Ethernet. Remember what we called this? Somebody gave the name for that kind of address that I just highlighted? That's a MAC address, what we call a MAC or physical address. And then down below, you see the IP version 4 address and mask and gateway setting there. And then you see here, these are IP version 6 addresses, okay? And so we represent MAC addresses and IP version 6 addresses not as just decimal numbers, but the number system. Does anybody know the name of this number system that contains the digits 0 through 9 and letters A through F? Nope. Hexadecimal. Hexadecimal. So we're going to, in class later, we're going to go through decimal. Y'all been working with that since kindergarten. Hexadecimal and binary. So we're going to go through 2 alternate number systems. And number systems are just different ways to represent a value. So the IP version 6 addresses and the MAC addresses are in a hexadecimal number system. And keep in mind, there's an address space. Everything that a computer does is in the binary number system at the base level, instruction sets. And an IP version 4 address, while we look at it in dotted decimal, in the computer's view, it's 32 ones and zeros is how it's represented by the computer. A string of 32 ones and zeros. It's a 32-bit address. These IP version of the MAC addresses are 48 bits long, so they're a little bit longer, okay? Larger address space with the more bits. These IP version 6 addresses are 128 bits long. They're extremely long, providing for a very large address space. What was the main problem with IP version 4? Why are we moving from this address format to this one? Because we're running out of IP version 4 addresses, public ones. And we need a larger address space. So we're going to get into that later in the class. So a little bit on IPv6 here. We'll talk about different kinds of IPv6 addresses too. I've been using the term interface or port. They can be physical or virtual. Like they can be physical things we plug cables into and connectors into, or they might be a software interface, a set of code. We talked briefly about the difference between copper and fiber and wireless and such in the previous chapter, remember? I already, we went through how to set an IP version 4 and how to set an IPv6 address. If you're not setting it manually or statically, you're assigning it to obtain it automatically, and that's through the Dynamic Host Configuration Protocol, or DHCP. In IP version 4, it is DHCP. In IP version 6, it is DHCP version 6, as well as the hosts can auto-configure their own address using stateless address auto-configuration as an alternative to for dynamic addressing. We'll talk about that a lot more later. Stephen, you had to issue the no shutdown command on your virtual interface. For the most part, everybody, once a port becomes active, it'll bring the virtual LAN 1 interface will become active, and you'll be able to hit that interface. For some reason, Stevens needed a little kick, and that was through the no shutdown command. Normally, you don't have to issue that, but sometimes you may encounter that, and we did in class. It's infrequent, but it happens. They give you videos on how to do all this stuff that we did, using Packet Tracer, obviously. And in Packet Tracer, it's it's pretty much the same deal. If you need to go into your computer settings and change its IP address, where are you going to go? Yeah, there's a little tab. It says IP, or an icon, a tile. It says IP configuration. If you go to the desktop, just go right to IP configuration. And right up here, we can either use DHCP, but you typically, in our class, you'll be setting it up statically. Put in the address, the mask, the gateway. You don't need DNS settings. Down here, this is a separate sheet in a real computer, but you can even set up the IP version 6 stuff right there. And we will be doing that in the class. So as soon as you put that stuff in, it takes effect, and you close that, it'd be up. You could bring up a command prompt on your computer and ping stuff to see connectivity. Bless you. And remember, the terminal was the thing that we used to connect and connect to the switch or router to program it. So, that's how you get around Packet Tracer. That's it. What did you learn in this module? Well, probably a good bit. Getting around comfortable. There's a lot of stuff, commands we used. There is one that I didn't address yet, and that's the trace route command. That is if you want to see the intermittent hops that you're going through to get somewhere. So if you want to see all the intermittent hops you pass through, you can do a trace. In the Cisco iOS, it's trace route, spelled out like this. If you do it from a Windows command prompt, it's trace RT is the command you use. And then you can provide a domain name like www.kmart.com and see where you go to get to Kmart's website. You see all the hops you go through, all the different network hops. Or you can use it by IP address. So how does that differ from ping? Well, ping just tells you if you got end-to-end connectivity. It doesn't tell you the intermittent gateways you go through or hops you go through to get there. Whew, man. Running out of steam here. I bet you are too. I'm going to do just a couple things really quick just to show you here. Show IP interface brief. Show IP interface brief from the switch command prompt. And it's a handy thing, especially on routers. You can see the interface summary, and usually layer 3 devices. That's why I said routers. It's handy because not only do you then see the addresses IP addresses you've assigned, and then you see the physical status up or down, whether it's working or not, and then the line protocol up or down. And for an interface to be working correctly, you've got to be up and up. Okay, if it's up and down, it's not working. Or down and down, it's not working. If it's administratively down and down, not working. Okay, it's got to be up and up to work. If you're troubleshooting an interface, you can do something like a show interface gigabit 1024, show interface gigabit Ethernet 1/0/24, and it will give you more information regarding that kind of physical level stuff. So what you'll see here, again, for it to be working, the interface has got to be up and up. And then you'll see some stats like, well, what's the bandwidth, in kilobits per second? What did it negotiate in terms of duplex and the negotiated speed, the rate at which it negotiated? And then you'll see some 5-minute input and output stats. Okay, and this will kind of give you an identifier of what's going on with this interface. If I got a lot of CRCs, a lot of runts, a lot of interface resets, those are indicating issues, bad things going down. Okay, I think I pretty much hit all that, and there was... Okay, and the one thing about your assignments, and then I'm kind of done talking tonight, is, when we were doing all this stuff, I didn't do exactly what they told us to do in your assignment. That's your assignment. So, but they say, hey, use a console connection to access each switch. That's grabbing the console cable and connecting it up. Use class A and B to name the switches. Well, you're going to see they're in bold. I've got it highlighted so you can't really see. It's bolded. Anything that's in the directions that's bolded, what does that mean? Case sensitive. Type it exactly as shown or it'll be marked wrong. Okay? Like passwords and host names, they want it typed exactly as is.
So when we
Yeah, so when you're on the switch, here, let me get the thing on.
My instructions are different.
Yeah, yours will be different, and that's why that PDF sheet had the names blank and the IP addresses blank, because you can get served up a different topology with different names. So you got to, it'll be whatever's in your instruction sheet will be what you got to use, but it could be different than Stephen's. And encrypt the clear text. That was a service password encryption command. Message of the day banner. Configure the addressing. That was the interface VLAN 1 IP address, blah, blah, blah command. Save your configuration. What does that mean? What did we do to do that?
We
Copied, run, start, right? And verify connectivity. How do you verify connectivity? Ping. Yeah. So we did all that stuff tonight. And when you're doing this, it's going to be bad news for me when I hit the check results, because I didn't use the right names, or I didn't use the right IP addresses. I didn't do anything in packet. I was doing it on the real switch, and I didn't use what they were telling us to use. So all the red X's are things I would have gotten wrong. It'll turn green check marks when I'm getting them right. You can always go in and out to check how you're doing. Trevor?
So in the PowerPoint, it shows you if you don't know how to do it, it explains it, how to do all that.
Yeah. PowerPoint's got all the commands. There's videos that even walk you through using the commands, so they even show you with videos and describe it. I'm recording my lecture even, so that's playable on the internet as well. And when you're ready to turn in your work, you get it'll tell you your completion rate is 0%. Well, you get 100% here. Once you got that, you go ahead and do a file, save. Okay, and where is this thing getting saved? Right up in the title bar. It's in my downloads folder. This is the name of it. Make a mark of that, and that's what you turn in when you're ready to turn in. So save the file, close it, save your work. Now, I'm disconnected from the internet, so I can't click any more links or it'll dead out. But where do you go to turn it in? Click on the M1A2 Module 1 group assignment, the big bolded thing at the top. Click on it. It'll come up a page, and it'll have a browse computer. Hit the button, attach the file, and hit the submit button. Boom. That's it. Okay. Awesome. Pretty easy? Not bad?
What's the due date?
Oh, the due date is not for a few weeks out yet. Yeah, so we went through that at the start of class. I forget, it's in the calendar and in the schedule of activities. But it's we're going to do Module 3 next week. We're going to do Module 4 the week after. And the day after that, it's due. So it's due in 2 weeks.
So after we complete Module 3.
Yeah. So you got everything you need to do the assignment. When we cover Module 3, that's a lot of stuff you're going to need for the module group exam. That's going to cover Modules 1 through 3. Okay, let's see. Anybody got any questions? Okay, now, whenever you're in class, what I need you to do before you walk out the door is restart Windows. Do a power option and do restart. Don't do a shutdown, but do a restart. Because we have a program called Deep Freeze that's going to clear out any configurations or anything you've done on the computer gets wiped out so that nobody sees anything you've done, and it'll reset the IP addresses we may have changed so that the next class that comes in will have internet access without freaking out. Okay, so extremely important to do a restart in Windows when you're all done. As far as the equipment in the closet, it's usually just easier for me to walk in there and just boop, 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 right down the row than it is to have everybody try to squash in there and pull cables. So I'll take care of the cabling for you. Stephen, you got a question?
Just about cabling.
Okay, I'll take care of that. Any other questions? Y'all know what you need to do for next week? Awesome, good. If you have any questions during the week, don't hesitate to give me a call.